In this lecture, I will share kinetic energy and potential energy of a freely falling body. First of all, let us try to understand what is the meaning of a freely falling body. Suppose this is ground level and a body is lying at some height. Suppose height of body from the ground level in the starting is h. If this body is dropped freely without giving any speed initially, then this is called free fall of the body. Means velocity speed of body at the starting point is equal to 0. Let me call this position as position A. During its fall, let us consider any other position. Suppose it is position B. When it reaches here, suppose the distance traveled by the body from position A to position B is x. Its velocity will increase from 0 to some new value. Let us suppose speed of the body at this point is v1. Similarly, as it falls down and reaches last point, that is on the ground level, let me call this point as C. At this point, speed of the body will be maximum. Let me call this maximum velocity as v3. So this type of motion of body starting from zero speed up to ground level is called free fall of body. Our question is, what is kinetic energy and potential energy at point A, at point B and at point C? That is to be calculated one by one. First of all, let us consider point A. At point A, speed of the body is 0. So this means kinetic energy of the body half mv square will be equal to 0. Because distance of body from ground level is h, so its potential energy will be equal to mgh. So in the starting, kinetic energy is 0 and potential energy is mgh, where m is mass of the body, g is acceleration due to gravity. If I find total energy means total mechanical energy, which is sum of kinetic energy and potential energy. This will come out to be 0 plus mgh means equal to mgh. So this is the value of sum of kinetic energy and potential energy of body when it is at the starting point A. At point B, as we have supposed, speed of the body becomes v1, so its kinetic energy will be equal to half m v1 square. So now we have to find value of v1. Value of this speed can be calculated by using the formula. We shall apply equation of motion v square minus v naught square equal to 2as. This is to be applied for motion of body from point A to point B. When it moves from A to B, final velocity is v1, initial velocity is 0. So v will be replaced by v1 square minus v naught square means initial speed square equal to 2. Acceleration is acceleration due to gravity because body is falling freely. S means distance traveled from point A to point B. This distance we have supposed equal to x. So using this I can write v1 square equal to 2gx. So this is the value of V1 square. It will be put in equation for kinetic energy, and kinetic energy comes out to be half m V1 square means 2gx. After simplification, we get mgx. So this is the value of kinetic energy when the body reaches point B. Now what will be potential energy of the body when it reaches point B? Potential energy can be calculated as mass of body into g into height of the body from ground level. And when it is at point B, height of the body from ground level does not remain h, but it becomes h minus x because it has traveled a distance x. It will be mg h minus x. It can be written as potential energy equal to mgh minus mgx. So we have calculated kinetic energy as well as potential energy at point B. What will be sum of these two? Kinetic energy plus potential energy at point B. It will be equal to mgx plus mgh minus mgx. After simplification, we get kinetic energy plus potential energy equal to mgh. So this is the sum total of both types of energies when it is at point B. Now we have to find both kinetic energy and potential energy when body is reaching point C. So at point C, kinetic energy will be equal to half m v2 the square because we have supposed here speed of the body as v2. So how to find the value of this speed at last point C? Again we shall apply the formula v square minus v naught square equal to 2as, equation of motion. So using this for motion from point A to point C, this point to this point. Finally, speed is v2, it will be v2 square minus v naught square means initial, that is 0 square equal to 2. A means acceleration due to gravity here. What is s? S means distance traveled is h, 2gh. This will give us v2 square equal to 2gh. So this is the speed of square of speed of body when it is at the ground level. This will give us kinetic energy is equal to half m 2gh. After simplifying, I can write equal to mgh. We have calculated kinetic energy of the body when it reaches point C or at the ground level. What will be potential energy of body at point C? Potential energy means mass into acceleration due to gravity multiplied with height from ground level. When the body is at point C, its height from ground level becomes 0. So we are left with mg into 0, that is 0. So we have found potential energy as well as kinetic energy at point C. So sum total of two types of energies, kinetic plus potential, will be equal to mgh plus 0, that is equal to mgh. So we have found sum total of kinetic and potential energy at all the 3 points, point A, point B and at point C. It is clear from all the results that sum total of kinetic energy and potential energy of a freely falling body remains always equal to mgh. Means total mechanical energy of the freely falling body remains conserved. Total mechanical energy means sum of kinetic energy and potential energy. That's all.